Welcome back. In this video, we look at multiplicative inverses of integers modulo a positive integer n. Let's let a and b be integers and let n be a positive integer. We say that b is the inverse or the multiplicative inverse of a modulo n if a times b is congruent to 1 mod n. If b is the inverse of a, then we write b equal to a to the negative 1 modulo n. Now notice that to find okay, let me give you an example first. So since 3 times 5 is 1 mod 7, we see that the inverse of 3 mod 7 is 5. Okay. So since 3 times 5 is 1, the inverse of 3 is 5, modulo 7. Now you can see that to find the inverse of a, we basically have to solve the linear congruence ax is congruent to 1 mod n. Now we know that this linear congruence has a solution if and only if the GCD of a and n divides 1. Therefore, this linear congruence has a solution if and only if the GCD of a and n is 1. Which means that this linear congruence has a solution if and only if a is relatively prime to n. Now, when n is a small modulus, then we can find the solution x by just using a brute force method where we plug in the values 1, 2, up to n minus 1 for x and see which one gives me 1 mod n. Now if the modulus n is big, then I suggest that we use the extended Euclidean algorithm to solve this linear congruence as we did in the previous video. Okay, so that's all I want to say about multiplicative inverses. There are a couple of exercises on this. In the next video, we will be looking at Fermat's Little theorem.